Hello. Today we will be discussing a beautiful mathematics problem from JEE Mains. And JEE Mains is considered not to be so difficult, but still in mathematics we see very beautiful questions sometimes. And this is one of them, and it looks very complicated. We have a matrix A, and then we have to calculate this thing. And you have a to the power 4, a to the power 10, adjoint of 2a to the power 10, and you have to do these operations. So I am a simple guy, I don't know about a lot of formulas, and I will do it from a very basic perspective. Like if anybody knows about the basic operations of matrices, he or she will be able to do it. So the thing about these questions, when you have these a to the power 4, a to the power 10, sometimes you can also have a to the power 2000, something like this, a very large power. So it's basically you are multiplying a matrix again and again a long number of times. So in these kind of questions, I personally believe that you should be able to figure out the pattern. So it's about pattern recognition. So this is interesting because what is mathematics? So I was reading this national curricular framework which has been drafted I think 1 year ago, I don't exactly remember, which is a part of the national education policy. And in that, in mathematics education, the definition of mathematics has been given as mathematics is about pattern recognition. But then I disagree, because this is not the only concern of mathematics. However, pattern recognition is a very important part of mathematics. So we are going to understand the pattern behind it. And I have done a lot of other questions of JEE Mains also, and this one was special because the pattern was not so easy to figure out. However, as we know that this is, and when you multiply two matrices, so you will use only this addition multiplication, so linear combination is happening, and the pattern should not be that difficult to figure out if it is a 2 cross 2 matrix. So let's see, if you have this matrix and this matrix, you multiply it, what do you get here? So first you have to multiply first row and first column, and then you will see that the 2 will get multiplied to 2, and then the other term will be 0. So this is good, and this is the real deal. This element which is in the first row and second column, this is going to be complicated. The element in the second row first column is going to be 0 always, and the element in the second row second column is going to change from +1 and -1, as you will see. So here it is 1, because -1 times -1 is going to be 1, right? Let me check. Second row and second column, yes, it's going to be 1. So this is easy. Something happens here, and it gives you 3 again. We'll talk about this. Let's multiply it again, and let's see what happens now. So here you will see in the first row first column, you will get you will multiply this and this, and you will get 8 here. So this is going very nice. It's the number in the first row first column is doubling up again and again. But something happens in this part. What is happening here? And you get the result as 9 here, and here there will be 0, and here there will be -1. So you see, it's the element in the first row second column which is a bit complicated. And then if we multiply it again, what is happening? So if we compare it from initially what we had. So initially we had 2, 0, 3, -1. Then how it changed? 2 became 4. This is always 0. This became 1. -1 to +1, and then again it will go to -1. But here 3 is 3. So when you square it, when you multiply it again, so 3 is going to be like this. You have 8 here. So this doubling, you can see this is very clear. 0 -1, but what happened here? This is 9. Okay, and again next time 8, say yes, this became 16, this is 0, this is now -1 to +1, but what happened here? This is 16. Well, can you see the pattern? What is happening here with I mean, we can of course see the pattern with the first element, but I'm talking about I mean the next, if we have to guess the next one. So 16 will become 32, right? 0 will be 0, 1 will change to -1, 1, -1, 1. So the next time if you have a 1 here and you multiply again this matrix, you will get a -1. But what is happening here? Can you guess it? I mean, first you can guess, and then you can also figure out the proof why what is happening here. So the first idea is like identify the pattern, what is happening. So the disturbing thing about this is like first time 3 remained 3 when you had a, and when you did a square 3 remained as it is, so it might give you a little bit of trouble. And then you did a cube, it became 9. And then a4, it became 15. What is happening? This doesn't seem to follow any kind of APGP kind of thing. This is intricately related to the nearby element, if you can see it. So take your time, see what is happening here, and then only if you are tired and you're not able to figure out, I think it's not that difficult. But first you have to try on it on your own, what is happening here. So the thing is, what is happening here is you see 2 plus 1 is 3, 4 minus 1 is 3. I am connecting the second element in the first row to the first element in the first row, and I see the pattern here. 8 plus 1 is 9, 16 minus 1 is 15, and if you solve it, you will get 13 plus 1 here, 33, if I am correct. So that is the thing which is happening when you are multiplying this matrix to itself again and again. I will show you why it will always be true, because you see we are thinking about this element, right, which is here. So this is second row, no sorry, first row, second column. So first row, I take the first row from here and second column from here and multiply them. What do I get? So don't think it in terms of 2 and 3, let's think it in terms of n and n plus 1. If you have in the first row n and n plus 1 and you multiply it to this matrix and you have 3 minus 1 here, what do you get? The element turns out to be 2n minus 1, right? So then in the next, like when you have multiplied n and n plus 1 to 3n minus 1, this happens and this is the term in the first row and second column, but the term in the first row and first column is getting doubled again and again. We have already thought about that. So this n will, the next time it will become 2n, and this n plus 1 will become 2n minus 1, and then you multiply 3n minus 1 and figure out the a12 element. What do you get? You get 4n plus 1. Okay, so in the next step you are, this element will become 4n because this is the first element, and the second one will become 4n plus 1. So we are back to this n plus 1 type of situation, and then this pattern will keep on repeating itself. So once you see this pattern, this question is very easy to solve afterwards. If you don't see this pattern, and if you don't know about some very like interesting properties of matrices and determinants, then you would not be able to figure this question out. So I have been there, I have faced these kind of situations, but I always like the fundamental approach. So what's going to happen? So now we can solve this question very easily. So we have a, so a to the power 4 will just be 2 to the power 4, and since we have this multiplication 4 times, so if this is a to the power 1, right, when you do a to the power 2, when you have a to the power 1, this number is plus 1. When you have an odd power, when you go to an even power, this becomes 4, and it remained again 3, right? So this is minus 1 and 0 plus 1, sorry. So when you are at the even power, this element, the second element in the first row is 1 lesser. So this is why this is 2 to the power 4 minus 1, and this number will be 1 because of obvious reasons. So you have a to the power 4 like this, then you can also think about a to the power 10, okay, so which is very simple, it's like this, and then you have 2a because you have to figure out the adjoint of 2a. So you have 2a, and then you can think about this adjoint. You have to take the cofactor matrix and transpose it. So after you get this, and then you have to do the power 10 of this matrix also, and this will also follow the same kind of pattern. You just have to multiply it a few times. There is you can take this 2 common out, and then you can think about it. So 2 to the power 10 will be common because of this 2 here, and then you have to multiply this matrix 10 times. And this is not so difficult. You multiply a few times and you will get the pattern. So when you multiply it a few times, what happens? So first multiplication will give you -1 will be changing to 1 here, -3 will remain -3, okay, 0 will get 0 here, this 2 will become 4 here. So you will figure out that this is the term which is doubling again and again, and this is following some kind of +1 -1 kind of rule with a negative sign this time. So I leave it for you to figure it out. So when you go on multiplying this, you can see again you get an 8 here, and then you have 8 plus 1, 9, but with a minus sign. And this term is changing from -1 to 1 to -1, and this will of course be 0. So this way you can figure that matrix also, and this turns out to be like this, and rest is all, I think, just rearranging in the simple things. So you can figure this thing out afterwards. I think what happens when you look at this thing, this matrix here, you have a to the power 10. This one we just figured it out, it was like this, and you have a to the power 10, and that was like this, and when you subtract it you get 2 zeros here, and because of that the determinant will be 0, and you just have to figure out this part, and that will be your answer. Thank you.